Hi everyone, this is Mrs. J, and today we're going to be talking about similarity in right triangles. So as a little warm-up, we're going to complete this chart. This is just to help us remember how to find the hypotenuse of different right triangles. So you can see here that within this figure, there are actually three different right triangles. So there's triangle ABC, which would be our large triangle. Our medium triangle would be triangle CDB. And then this is also a right triangle because if this is 90, so is this. So our small triangle would be triangle ABD. So it's really important that you know how to look at a right triangle and determine where the hypotenuse is. And that can be done by simply looking across from your 90-degree angle. So here, our 90-degree angle is right here. If you look across, that means our hypotenuse is AB. The medium side of this triangle would be BD, and the small side is AD. So for our medium triangle, triangle CDB, again, look across from your 90-degree angle, and that's always your hypotenuse. So BC. Our medium side would be here, and that's segment CD. And then our small side of that triangle is right here, DB. And last, for our large triangle, triangle ABC. B is our 90 degree, so if I look across, this entire segment, AC, is our hypotenuse. The medium side would be BC, and our short side is AB. So again, it depends on which right triangle we're working with to decide what is our hypotenuse, medium side, and small side. Okay, so now we're going to learn about what's called the geometric mean. So let's look at this proportion setup. A over x equals x over b. So you can see that on the left side, x is in the denominator, and on the right, x is in the numerator, where two of the numbers in the proportion are the same, so that's that x value. The number x is what we call the geometric mean of a and b. So the geometric mean of two positive numbers is the positive square root of the product. So imagine you took this proportion and you cross multiplied. So I can show that right here. What we end up with is x squared equals AB. And so then we would take the square root of both sides. Usually we would take the plus or minus, but if you look at this definition, it is the positive square root of the product. And remember, product tells us to multiply. So again, if you multiply the two numbers and take the square root, that's your geometric mean. Or instead of doing this, you can actually set up this proportion and cross multiply to solve. So this says find the geometric mean of 4 and 9. So again, we can just take the positive square root of their product. So here we get square root of 36, which is 6. Or we could set up that proportion. We could say 4 over x equals x over 9. Cross multiply. X squared equals 36. And then x equals square root of 36. We're just using the positive one, so x equals 6. Okay, go ahead and pause the video and see if you can find the geometric mean of 3 and 20. Okay, let's check our answer here. So either you can just take the positive square root of the product of the two, so you get square root of 60, which can be simplified to 2 root 15. Here I kind of showed the work. 60 is 4 times 15, and if you notice that 4 is a perfect square, you can simplify it to 2. Or, of course, you can set up that proportion. 3 over x equals x over 20, and you can cross multiply and solve. You'll get the same exact answer. Okay, so the reason why we were learning about geometric means is because there are two geometric mean theorems involving right triangles that we can actually use. So here we have a right triangle that does have an altitude. It is important that we have dropped an altitude that connects our right angle to the hypotenuse, which is C. So this is our hypotenuse. So the first theorem says that the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So this is a little bit hard to interpret, so let's go one step at a time. The length of the altitude, so that's h. So you can see h right here, is the geometric mean of the lengths of the segments of the hypotenuse. So this is our hypotenuse, and these are the two segments that are created from the altitude. So h is the geometric mean of x and y. So that's why we see that h is the positive square root of the product of x and y. The second theorem states that the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So another kind of tricky one to interpret. So let's go through it together. So the length of a leg, so let's say we start with A. It could be A or B, and we can actually do it for both scenarios. So the length of the leg is the geometric mean of the length of the hypotenuse. So our hypotenuse is C. And the segment of the hypotenuse, right here, that is adjacent to the leg. So adjacent is the key word here. Adjacent, remember, means next to. So that adjacent part would be x. So again, the length of the leg is the geometric mean of the hypotenuse and the part of the hypotenuse that is next to that leg. So here you could say that A, the leg, is the positive square root of the product of x and c. We could do the same for the other leg. So B should be the positive square root of the hypotenuse and y, which is the segment of the hypotenuse that is closest to B. Okay, so let's see if we can use those theorems to help us find x, y, and z. So the first one we can find in example 2. You'll notice that here we have the altitude and that we know the two segments that make up the hypotenuse. So let's use that first theorem. The altitude, which in this case is x, is the geometric mean, so it means the positive square root of the segments of the hypotenuse, 10 and 20, or 10 and 2. So I take their product. So x equals square root of 20. So 20 we know is 4 times 5, and 4 is a perfect square. So that will simplify to 2 root 5. So we have solved for x. Let's see if we can now solve for y. So we're going to use the second one here. The length of the leg, so let's say y, is the geometric mean, so it's going to be the positive square root of the hypotenuse. Now here, remember the hypotenuse is going to be this total length, which is 10 plus 2, so 12. And the segment that is adjacent to y, so that would be this side length, which is 10. So here y equals the square root of 120. So to simplify, if we think of 120 as 4 times 30, this is a perfect square, so y equals 2 times the square root of 30. Okay, and now last we need to find segment z, so we can use the same theorem that we did for y. So the length of one leg, z, is the geometric mean of the hypotenuse, so 12 again, and the segment of the hypotenuse that is adjacent to z, which would be 2. So here we get the square root of 24. 24 is 4 times 6, and again, the square root of 4 is 2, so 2 root 6. So there you have it. Okay, for this last one, why don't you pause the video and see if you can try to find x, y, and z on your own, and we will check your answers in just a few seconds. Okay, let's check our work here. So here x is our altitude, so we know the altitude is the geometric mean of the two segments that are formed by the altitude in the hypotenuse, so 5 times 7. To find y, we do the leg is the geometric mean of the total hypotenuse, which is 12, and the portion of the hypotenuse that is adjacent to y. And then last, for z, this leg is the geometric mean of the entire hypotenuse, 12, and the portion of the hypotenuse that is closest to z, so 7. And here you can see how I simplified my radicals. All right, that is all for today's video. Thank you so much for watching.